We'll continue our discussion of the top 10 web security threats. So last time we have seen injection. Anyone can quickly remind us what is the idea of injection? Sorry? Showing malicious strings, yes. So typically you have some kind of command interpreter, some kind of component that receives commands as a string and executes them. So the attacker takes advantage of this and it sends malicious strings, malicious commands to this interpreter. So in some kind of input field, instead of typing a value, they put a command. And that command goes to this interpreter, and the interpreter will execute it and either reveal some information that the hacker is not authorized to see, or do some damage to the data, or do some damage to the unwanted damage. Okay? And the example of this is the SQL injection and other types of attacks like denial of service attacks and stealing data, destroying data. A lot of scenarios are there. It's very common and very, very dangerous. And how to prevent it? What is the mechanism to prevent this? Yeah, as much as possible not to use these interpreters, but sometimes you have no escape. Like, for example, you're using SQL Server, and the server is really an interpreter. It accepts SQL strings and runs them and gives you some results or do some changes to the data. So in this case, you have no escape but to use it. But when you use it carefully by validating the input. Very, very important. Validating the input can solve a lot of the security problems can be avoided by data input validation. Like, for example, if you're expecting a string or a number, make sure the user gives you a number. If you know the range, make sure the number is within that range, and so on. So validation could play a major role. Also in SQL, when you're using SQL, don't use string concatenation to build your SQL statement. Instead, try to use parameters. You have seen this in GPQL. You use parameters, then you set the values, and then you execute the query. Don't use concatenation to build the string, to build the query. So we already discussed this, and a video has been posted about it. And these are the main things that you can do to protect your application from injection. Second thing that is very common is broken authentication and session management. So sometimes under the pressure of time or maybe the lack of expertise, developers just rush developing authentication. Authentication is the screens or the mechanisms to let the user into the system. And here, the attackers can take advantage of those weaknesses and flaws and take advantage and come in and attack your system. These are some common scenarios. Sometimes you log into some computer, especially public computers, and then you basically close the browser without logging out. Somebody comes after you, opens the browser, they go to that particular application, and they can use the application without entering their username and password again. So how to solve this? Sorry? Yeah, for users, you cannot force them to log out. Of course, you encourage them, you provide the logout, very important. Always provide the logout. Yes, please.
Duration for the session to be ended after live?
Very good, yes. So basically put a session timeout. Most servers have some default timeout. Some others you have to configure them. Like Banner, for example, if you remember, whenever you use it after 20 minutes, if you do no activity, it will invalidate your session and you have to log back in. So using this session timeout, you reduce the likelihood of this happening. Second thing is the session hijacking. So somebody manages to steal your session ID and they can get into the application as if it was you, okay? And they can steal your session by maybe sniffing the network and basically grabbing the session ID. So let me show you this scenario. It's very, very easy to replicate. So let me open our OWASP. Remember this application that I showed you, Node Goat? Very, very good application to really understand what's going on. So let me try to see if I can open it. Okay, so it's already open. Okay, so what I will do, you see in here, if I go here, under cookies, there is a cookie here, this connect ID. So Node.js, when you log in, it creates a session on the server side and communicate the session ID to you using a cookie named connect.id. Here is your session ID, which is like an auto-generated, a long string, very hard to guess, which is good. And here is from where it came, and here is the path it came from. And whenever I visit this website, this cookie will be sent back to the server. So somebody somehow, using packet sniffing, or somehow they managed to get this session ID. Or they use something called cross-site scripting. I will explain what it means shortly. So if they manage to get this cookie, they can go to another browser and create this cookie and then come into the application without username and password. So we can try to do this very quickly. So I'll take this connect ID. I go to Chrome. Just close this. All right. If I just go to localhost 4000, no, let me just do it properly. Just give me 1 second, please. I will Smith. Let me just log out and log back in. Okay. So let me show you in here, in Chrome, if I do localhost 4000, it will ask me to log in, isn't it? So, and imagine this is one user using Chrome and the other user is in another computer using whatever they want to use. So somehow they managed to get the cookie details. Here is the authentication cookie, which is connect ID and so on. So what I will do, I will just recreate this cookie in Firefox so I can hijack this session, take over this session. So you come here. There are a lot of plugins to help you do this very easily. And one of them is Cookie Manager. So I create a new cookie. Here is the name of it. Here is the value. Okay, it came from localhost / and then I'll save it. So it's saved. Now if I go and do localhost 4000, I am in without any username and password. So this is called session hijack. If somebody gets your session ID, they can come in without the system asking them for username and password. So how to prevent this? What is the mechanisms to prevent this session hijacking?
Don't show it. Show it encrypted, or I don't know.
Show it encrypted. Very good. So in the login page, always have your login use HTTPS. So the communication between the client and the server will be encrypted. So even if somebody comes in and sniffs the traffic, they cannot see the session ID. It will be encrypted. So that's one mechanism. The other one, of course, you try to always have a session timeout. So even if somebody managed to get your session, hopefully by the time they get to the time to use it, it's already expired. But using HTTPS for sensitive pages like login is very, very important to avoid this session hijacking. And the other example is the other scenario related to authentication is that the hacker gains access to your system, to your file or database, maybe using injection, and they can see the username and passwords. And of course, once they see the username and passwords, they can use them to log in. So how to avoid this? encrypt. Whenever you have passwords, don't do like our homework and project and put them there in the file, clear, in a clear text, always encrypt them. And most of the tools like Node, JavaScript, or Java or .NET, they all have functions to very easily encrypt and decrypt. The other one is this hijacker. This is like kind of a beginner. They couldn't do any of these. So what they will do, they will try to guess passwords and try to do brute force, guess passwords. And there are tools to give you very good password, very good password guess. So how to avoid this?
Make it long.
Yes. So when you ask the user to create an account, yes, put restrictions that the account, it has to be 8 characters. You have seen this. It has to be alphanumeric, special characters, and so on. So you make it as complex as possible. Okay. Don't allow simple password. What other mechanism you should use to avoid this? What happens if you try to log into your email more than 3 times? It will be locked. So lock the account after certain attempts, maybe usually 3. After the 3rd one, your account will be locked. So even if you try guessing, you will not go anywhere. So these are the typical attacks, and each one we discuss the mechanisms to avoid them. So here, this is the summary of the discussion we just had. The other very common attack is called cross-site scripting. Cross-site scripting, also known as XSS. So what is this cross-site scripting? Any idea? Very common. So let me show it to you in practice, and then I'll explain it. And hopefully from the example you can work out what it means. So here is the profile, okay? And then here, this is an input text box. It's expecting from me a string. Instead, what I'm giving it, a script. When I submit this form, what will happen to this script? No, it will be saved to some database. It will not be executed. Yeah, it is just a string. In the database, you will see the column last name will be this script. It is a string. Okay, no problem. So up to here, there is no problem. And by the way, this attack is not targeting the server side. It's targeting the client. So now the client comes in. Let's say I logged in. Okay, when I log in, it will show me. You see here. It will show me the username and password. Sorry, not the user, my full name. Yes, first name, last name. So here's the dashboard. See here, it showed me the first name, and the last name is a script, so it executes it. Of course, in here, the hacker will not do this and show you the cookie. What they will do, they take this cookie and send it to their server. And then they can hijack your session. Are you following? So basically, based on this example, can somebody explain what is cross-site scripting?
It does something with you and sends to the server.
So how do we?
The execution will be in the client side.
On the client side, but how does it get produced? What the hacker does to achieve this cross-site scripting?
Sending the string instead of a string.
Yes, you have some kind of form, okay? And the hacker knows that the data in the form will be saved somewhere. And of course, there are users that will go in the future, go to your database or file and get that information and display it on the browser. Okay? So it's cross-site scripting. Is it targeting the client or the server? The clients. They don't care about the server. Server is just a kind of something in the middle, where we store this malicious JavaScript code, and when the client comes to retrieve the data from the server, they get the malicious code to run in their browser. Okay? And then the malicious code could do something like read the cookie and send it off using services, send it to the hacker website. It could change this page. It will say to you, it can create a little login here and it says to you, sorry, we ask you to log in again. And they ask you for username and password, you type them in, you send, and then where it gets sent? To the hacker. And they can go and log in as you. Okay? Or they can route you to a malicious website. You know, JavaScript, you have all the power. You can redirect the user to another website. And that website could be prepared in a way, for example, this is QNB. It can look like QNB. And it will ask you what is your password. It can, okay, and take all the information from you. Or it can download some, sorry?
How can we know that this is malicious?
How can we know? No, you basically need to be aware of this and do some preventive measures to avoid this. And what is the how can we prevent cross-site scripting? Validation. You see here, inputs validation is very, very critical. And by the way, don't rely on inputs validation on the client only, because very easily you can bypass it. You can submit a form by script without even going through the browser. So you have to do validation on the client side and on the server side. Very important, because this could be avoided very easily. Here it is. This can be avoided. Have you seen any last name that has less than, greater than? No. Or has script? No. You can easily do validation. Or it's this long. I haven't seen any last name this long. Okay. The other one you can do, so validation is very, if you do validation, this will not be produced. The other thing you can do, if it is too long, let's say a job description or some kind of report, you cannot really do a lot of validation. You can do what is known as blacklist keywords. Like you can search if there's a keyword, yeah, like script or less than, greater than, you can make it kind of suspicious. You can raise a suspicion flag, or you can just encode it. Encoding means encoding is just. Let me just show you. So the less than and greater than will be replaced by the corresponding encoding. Yes, and this one is harmless. So if I put this and come here. I mean, on the server side, let the client put scripts they want. It's fine. But when we accept it, we encode it. And when we store it, it will be stored encoded. When the clients come and get it, this script is harmless. You can see here. You can see it, but it's not because it is encoded. When the browser shows it, it will decode it, but it will not execute it. You see here, welcome, and this is the script, but because it is encoded, it's harmless. So very easy to avoid it. So either data validation or encoding. That's how you avoid this cross-site scripting. So let me just explain it one more time, what this cross-site scripting means. So here is a scenario. So there is a website that, let's say Qatar Living, for example, where you can post jobs for people to view. So for the normal users, they will type genuine job description. We're looking for, let's say, web developers with security skills, whatever. And then they will save it. But for malicious ones, they will put some strings, some text, and some script also. And let's say something like Qatar Living are not doing, they are not aware of this, and they didn't validate, and they did not encode. So what will happen is, like when the user submits that job description, it will be stored in some kind of server or database or some kind of file, and then when the visitors come, they search in for a web application development job. They search and they will get the results. So the job description will have script that has some harmful commands. Either harmful means here, either it will basically like steal the cookies and send them to the hacker. It might change the page. It might, these are the main things. It might redirect you to some malicious websites. So, but your imagination is the limit here, because you have a full scripting language that you can use to do whatever you please. Yeah.
What is the advantages of having the cookies of other persons? What?
Yeah, we just, maybe you missed it. Basically, if you have a cookie of somebody else, you can go to another browser and create those cookies, and you can get to the application without you logging in. We just did it together here. Yeah, very dangerous. If somebody gets your cookies, especially the cookies that have the session ID. Because when you log in, the server, as we discussed in the previous lectures, the session is communicated to the server, from the server to the client using a cookie, and then that cookie is stored in the browser. And then for subsequent visits, that cookie will go back to the server side. And the server will say, oh, you have this session ID, so I give you access to this session, and I will not ask you to log in because I know who you are. So if somebody has your session ID, of course, they can impersonate you. They can act as if you are using the application. So yes, it can be very dangerous. Yes?
For the security, it's limited anyway for some number of rows. You cannot write the wrong script or something. So
Why is that? What do you mean? Like
in this case, a description, will have.
it's just like in one line you can, in few lines you can do a lot. So just let's say 500 characters or 100 or 200, you can do a lot. Yeah, it doesn't take too long. Sorry? Yes, before as I showed you, it can, like I showed you in the SQL injection, attack, or in the injection attack, this one is enough to bring the whole server down. Okay, so it doesn't usually take a lot of script. If the door is open, and by the way, as I mentioned to you, the user interface can be bypassed altogether. You can use something like Postman or some tools that are even more sophisticated, and you can send a request without having a phone. So all the limits, all the validation that you have on the client side have no value. They can be bypassed. So validation must be done on the server side as well to protect yourself against this. So this script can do a lot of damage. It can steal the cookies and send them to the hacker. They can even change the page, and they can show you a login page that looks like genuine login page. You type your username and password, and they will send to the other. That's how, and they managed to do this. This is very, people manage to do this. That's how they take over accounts. You hear Facebook account or Twitter account of this organization has been taken over. These are examples of how they do this.
But they started in a bank, even
Yeah.
They steal all the accounts.
Yes. This is very real and very dangerous, so you need to be aware of it. Now, the other one is called insecure direct object reference. Insecure direct object reference. Here, what you can see here, this is curious users. You can see here there is a shopping card ID 423246. This is the one that belongs to you. But you can guess, just for curiosity, you want to see the shopping cards of others, you can just change this number. Okay? You see here? So this is called insecure direct object reference. This is very common, and usually developers, they don't even think about it. That users will try to guess other inputs to see them. So let me show you this live in this example. Here are allocations. You can see here are my allocations for John. I can go and say 4. Error allocation not found. Yeah, that's fine. 3. Will Smith. Okay. So this is not this is John, but I am accessing Will Smith instead. You see here, this is called indirect object reference. Insecure direct object reference. Sorry?
We are looking at Will Smith.
No, basically I am accessing the allocations of this guy. Okay? So is there one? Just to try. Here you just try. There's another one. Admin. Okay? So the idea here is that from the URL, because here you have some kind of a design trade-off. You want to make your URLs meaningful and friendly, but you are opening them to easy guesses. Okay? So you have to balance it. But how can you avoid this? Sorry? This will not help. In big numbers, you can write script to try a lot of big numbers. No, it will not help. You mean you put some long generated ID and then you translate it to this? Yes, it can help. But you basically revalidate whenever somebody wants to do an action, check if they have access to it. For example, you can only see your grade, as an example. So when you try to go to your, let's say, grading /1, 2, 3, 4, if you try to do grading /2, 3, 5, 6, you as developer, you validate that you only have access to to see 1, 2, 3, 4. You cannot see others. So you do authorization. You validate the authorization every time the user does an action. So you don't just leave it open. Is clear? There is something called, like what the developers usually do in their mind is known as security by obscurity. What we have in mind is that because the user is not able to see it, it means it is secure, they will not access it. So there is no link here to get me to 1, which means, khalas, if the user does not see it, means they will not think they will access it, okay? But it's not the case. The users, because here, for example, here I have contributions. Some users will even think about, there is another example here, let me remind myself. Benefits. Since there are contributions, they might be benefits. So curious users or malicious users will try this, and they will access benefits. Although benefits are only accessible to administrator. Okay? So, of course, in our homework project, all of them are open to this type of attack. Because when we log in, we show the links only for the links that the user have access to. But we assume that the user will not guess the other links, especially if they are obvious. Like, for example, if they say /coordinator, /student, /manager. So they will say, oh, I'm student. Why can I try /instructor? Why can I not try /admin or /coordinator? Okay? You see here, like, from the URL, they can... Yes, very good, yes. You get the idea. So this is called insecure direct reference. So basically what you do is, this is for the old web pages. You can see sometimes they ask for, the page that you want to ask for is a parameter. So the users, especially the ones with malicious attacks, or sometimes even curious, they will try to guess other files. And they might even ask for a sensitive files to be returned to them. So in here, again, what you can do is, as some of you suggested, instead of using these obvious numbers that are easily guessable, you can do some kind of mapping between some complex ID and this real ID. And then in the URL, you show the complex ID. When it comes, you map it to the real ID. Okay. And basically, you have to validate the authorization again. You make sure the user have access to the URL or to the resource they have requested. And don't just say, if it is obscure and not visible in the UI, it means it's secure. That's not the case. The indirect object reference is very common attack. That you get the idea. Is it clear? All right. So this is how we avoid it. As I mentioned, instead of using guessable IDs, you use kind of harder to guess IDs, and you have some kind of map or a lookup table that maps the hard to guess with the real IDs. Okay, security misconfiguration. In here, as we saw, let's say in Node.js as an example, maybe what we write is maybe 20% of what we use. There are so many modules that we just do npm install and start using. Okay, so because you are using other third-party components, any security holes they have, you inherit them as well. So you need to be very careful. You need to follow up, especially those critical components. Let's say Express module, let's say body parser, those common ones. You always be alert. If they have any fixes or security patches, you need to apply them immediately. So usually, like there are kind of newsletters and websites where you can follow up on these patches and new updates. So whenever there is some patch or some security update, you need to go and apply it. Also, there is a process also called server hardening. Hardening means if you install a server, try to disable or maybe even not install things that you don't need and open ports that you don't need. So only install the minimum that is required and close any services or any components that are not needed. So in here, it's all about the whole stack, the operating system, the database, the components that you are using. Make sure they are well configured, regularly patched if there are any updates, because if there are any holes on those components that you are using, of course, you inherit them and attackers can go through them. And usually these holes become public. What I mean, the attackers, once they discover there is some security hole, let's say in Express.js, it become public and people, hackers will start exploiting them. So you need to really be very quick in responding, and if there is a patch or a fix, you should apply it so you are not subject to such attacks. Okay. Sensitive data exposure. Is this clear? Yes. This is more about following up components that you're using and always patching them and always making sure they don't have security holes. Sensitive data disclosure. Now, this is more as developers, we tend to do maybe in the console or when there is an error, we try to put a lot of information to help us debug the error. But those logs that we put, especially the ones that we return to the client, could reveal some sensitive information. Like it could say the IP address of the database. Let's say could not connect to the database located at this URL using this username and password. Sometimes, like especially when we have a problem implementing some functionality or debugging, we tend to add a lot of debugging information to help us discover the error. Yes, but before we go live, we have to make sure that we don't reveal any information. When there is an error, we don't reveal too much information. We just, some professional websites, you just say, we're experiencing some problems. Please try later. But they don't reveal to you what were the problem. Maybe the type of database you're using. You don't say the MongoDB at this location is down or and so on. So this is what it means. Also, even in the logs, when you log some information for IT people to look at it, you should not log something sensitive. You don't say the payment using this credit card number 123446 with the verification code 234 failed. Because that information, even from genuine users or some malicious insiders, there are not only the external attackers, there are also insiders, the insider threats. So in the logs also you need to be careful not to reveal sensitive information. So these are, that's basically the idea here. All right. Missing functional level access control is very, very similar to insecure direct object reference. So the insecure, here is the insecure direct object reference. In here you're accessing some kind of resource by ID. So you try to guess the ID, and if the application does not revalidate the authorization, it will let you go and show you data that you don't have access to. In here, the user or the hacker is trying to do the same thing. They're trying to do the same thing, but not by guessing IDs of resources, but by changing the URL to elevate it to another user. Let's say in here I have, let's say, so in here I have admin, add user, username and password. Okay, what this is trying to do. No, I think the one I gave you before much easier to understand. We have in our, let's say, override request, we have two roles. Let's say student and coordinator. So if you reveal, let's say in the URL, all the student functionality, you put it under the URL/student. So the curious user will try to guess, since there is a student role, there must be some other role. Let me try admin, let me try coordinator, let me try instructor, let me try manager. So they will try to play with the URL to try to see if they can access other functionality, unauthorized. So again, in here, you need to add the missing authorization. Like, as I mentioned, the key principle here, don't assume security by obscurity. Never assume, since it's not visible in the UI, the user will not think about it, will not even try to get there. They will try to get there. So that's why you need to check the authorization. Always check the authorization before you let them do whatever they requested. Okay, cross-site request forgery. Cross-site request forgery. This is again another famous. This is again another famous attack. The way this one works is, so basically, maybe I'll show you an example and then try to explain it. So here is an example. Let me go to profile. You see profile here, I have a bank account, a routing, bank routing. Let's say this is an employee, and this is the bank account in which the salary gets transferred. Okay, so let's say I am currently logged into this application, and then what I do, I visit another application, another web page or another web application, and that web application will try to send a request to this application to set these two variables or to set these two properties. Let me try to do it, and then I'll try to explain it further. So here is the cross-site forgery. So I will go to this URL, and what this URL will do, it will try to send a request to this. So here is the application that the attacker is trying to attack, and it will try to attack it from another application. Let me just show you. So this other application will try to send a request, a genuine request on behalf of this first application. So let me just show you. In here, if I click here, if I click this win, let me first inspect it just to show you what it's doing. When I click win, there is a form in that click. What that form is doing, it has two inputs that are hidden. You don't see them, they are hidden. And they are going, when you submit, when you click what the browser will do, it will submit this form to this URL. You see this URL? And since the user is already logged in, what this will do, it will send a request to this URL /profile, and it will set the bank routing to this value and the bank account to this value. Since this is already logged in, this is a genuine request. The server side will think that the user is asking it to change the account and the password. So the cross-site request forgery is that the attacker will create a genuine request. This is a really genuine request, and it will try to submit it, assuming, of course, that there is an active session on the server side. Okay? Because if there is an active session, this request will go through, and it will be accepted and executed. Okay? And that's basically the idea. Let me just show you here when I click win.
It's like the advertisement that sometimes appear and then if you click.
No, basically, look, the hackers, what they are targeting, let's say targeting a major, let's say in Qatar, if they do this kind of example here, in Qatar, they know the URLs of major banks, for example, okay? And they will have a hidden form in there that asks for transfer from this account to this account, and this is the amount, and send this to particular URL, okay? And they will use in many ways. They can use forums, or they can use this junk emails, sending people messages with the URLs to visit to subscribe to this, or to win this, or whatever. So, yeah. Yeah.
Can be like in advertisement a bit louder, like sometimes.
It could be anywhere. It could be in a genuine website, and this one is cross-site scripting injected. Oh, very good. If they do it, there is no session behind. This will not be, if there is no session, have a look at this. If there is no session already established and a session ID already in this browser, this will of course fail. Because for this to succeed, it is assuming that the user that is opening this page, they are also opening their bank account. Okay? Of course, this will not succeed if the user does not have an established session currently open. This assumes what? This assumes that there is already a session going to localhost 4000. If there is no session, there is no problem. So that's why if you don't need a particular, as a user, if you want to protect yourself, if you don't need a particular sensitive tab, you just log off. Because as long as it is logged in, you are open to cross-site request forgery. Basically, they forge or they create a request that looks genuine to the server side. It looks a genuine request. There is la ghubar alayh. There is no problem in here. If there is a session, the server will accept this request happily. So how to avoid this as developers? How to avoid it?
Okay, again, make a duration for the sessions.
Very good. This is always very good practice. Timeout of the sessions. What else? What does QNB do when you ask for transfer? Any of you? Yes, he sends you an authentication or a PIN number that you have to enter. or they will ask you to log in again. Okay, and this will fail. This will fail. You might get a message saying, oh, you want to transfer to this person 10,000 riyal. This is your PIN. Okay, and you say, oh, because you are here, you know it's a cross-site request forgery. So if I go back here, have a look at this. If I refresh this page, profile, see here, these are set from the other website. So this is the cross-site request forgery. Sometimes they might even not ask you to click anything. They can put the script in the source of an image. Have a look at this. Once the page is open, the request is sent already. Okay, as the source, in the source. But this one is more if you don't use post. That's why if you want to change something on the server side, usually use post rather than get. Because get is very, very easy to create the request. You see here, I am passing the parameters as a URL parameters. And this, without even the user clicking anything, as soon as they open, khalas, the request is sent. So to avoid this, as we said, use post instead of get, re-authenticate, and also expire the sessions as soon as you can, and also use hidden fields. So in the form, when use some kind of hidden fields, when you submit the form, the server expects some hidden fields. This hacker that cannot guess that hidden field, the value of that hidden field. What I mean is, QNB will send you the form to fill up to transfer. In that form, there is a hidden field that says my secret 123456. That secret will not be known to the hacker. So even if they try request forgery, it will fail. Yes, will not find it, and of course the hacker will not be able to guess it. Okay, so 2 more left. We will do them next time, using unknown vulnerable components and validated redirects and forward. Very easy ones, and then inshallah we will wrap up everything. All right, thank you very much. I will be there 12:30 to 1:30 if you have any questions. Otherwise, Tuesday inshallah. Assalamu alaikum.